Hello, today I want to talk about lists in Java. In particular, I want to talk about the list interface and the two classes ArrayList and LinkedList that implement that interface. And I already created a class called book. This class has three member variables: author, title, and price. It has a constructor that expects a title, and it has a few getter and setter methods for the member variables. And finally, it overrides the hash code and the equals method. And this is all this class has. So to demonstrate the lists, let's create a new class called main. Inside that main, I create the main method. And here I create a new instance of an array list. The array list will store book objects, so I provide that here. And I call that list, and I call the constructor on it. So new array list. And then I have an array list. Now internally, an array list uses an array, and I can keep adding objects to it. If the array list at some point becomes full, the array list will automatically create a new array of twice the size and then copy the elements over from the existing array to the new array. And then once it fills up again, it doubles the size again of the array. So internally it will handle all of that for us. We can keep adding objects to it, and we don't need to worry about the array list filling up. So to add objects to it, we just call the add method, and then we can pass in an object. So here I create a new book, Java is fun, and that gets then added to the array list. And I can add as many objects as I want. So this for adding objects. If we want to check if an object exists, let's create a new book object here. I call it book1, and I give it the same title as before, Java is fun. And I print out if it exists. So I do list.contains, and I pass in my book1. So the contains method returns a boolean, either true or false, if this object exists in the array list. Now this is important to implement the equals method. If I don't implement the equals method, this would return false, because it would then, without the equals method, compare references. Now because I implemented and overrode the equals method, it will compare the title. So it will compare any book that has the same title and same author. So in this case, it would return true. We can also check or get a book if it exists. And we do this by calling list.get, and we pass in an index. So the index starts with 0, that's the very first book. And then if I pass in 1, it would give me the second book that's stored at index 1. Java is great. Then let's print this out. Book at index 1. And now we can also get the size of the array list. And the size for the number of elements stored will be in size list.size. List.size will give me the number of elements in the list. There are multiple ways to iterate over an array list. So I can use a for loop. So the for start with index 0, I less than the size, I++, and here I can handle my book. and I get it by the index, so with the get method, and then I print it out or do anything else I need to do with the book. Another way is to use an iterator. So iterator is an interface, so I create a variable of that interface type with the element type that the iterator will iterate over, and then I call the iterator method on my list. So first we call the iterator of that list. This iterator will return a new iterator instance, and I'll save that in my iter variable. So I need to import iterator java.util, and then I can use that iterator. So iter.hasNext. The hasNext method will be true or false depending if there's a next element. So in this case, we just got it, we never called it, it will say true, there's a very first element, and then we can get that first element by calling iter.next. So iter.next does two things. It moves from the first book to the next one, so it advances the iterator by one, and it returns the object. So this one will give me the very first object, and now the iterator moved one further. So the first book here I just print out. The iterator moves one further. We call hasNext again. There's another object. Java is great. So the next method will return that object and move that iterator along. And then when we call iter hasNext again, it will return false. And the iterator, the while loop is complete. So another more convenient way of using iterators is the for each loop. That actually does the code up here, the iterator initialization, and the hasNext and then the next method internally. So for that we do for every book in our list we want to do something. In this case, again, I just print it out, and that is it. So this internally, the for each loop uses the iterator approach. And this is all for what we need for ArrayList. Now I mentioned at the beginning of the video that I would like to talk about the list interface. So we can declare the list variable here just as list, and the list is an interface. So I have to import that java.util list, and my code still works. So now my code actually implements against the interface instead of against the implementation. So the interface is really just has a bunch of methods that the concept of a list should support, such as contains, get, size, iterator, and many, many more. It doesn't implement them since it's only an interface. Then the ArrayList provides a specific implementation of a list based on arrays. Internally it manages an array. And another list class that implements the interface is the LinkedList. So again, I need to import this also from the java.util package, and the entire code still works as before, even though I completely changed the type here, because everything is built based on the list interface. So you might wonder, why should I use a linked list or ArrayList? It seems I can accomplish the same thing with either one of them. That is true, but typically once you know the implementation, there are performance differences. So an ArrayList, it really doesn't use anything at the beginning. Once you add objects, it actually creates nodes, and then for each node it references another node. So you might want to look into a data structure class or video that explains that in more detail. But essentially, for each object that you store, it is stored in a node object, and the node object, the only thing it does is store the element that you want to store and a reference to the next node. So again, there's no limit to it. We can add as many objects as we want. But if we want to look it up by a specific index, let's say we do get.1000, we would have to start at the very beginning of the linked list and follow all the references from node to node to node to node 1,000 times until we get to the one that we need. So the linked list is good if you just want to iterate from the very beginning to the end. And we should always use an iterator or the for each loop. It's not really good to use an index-based loop like we did here, since then we access it by index, and every time you would have to start from the very beginning of the linked list. Now with an array list, we can get access in O1 by the index. So we can access index at 1000. Internally, it compute the memory address based on the offset of the array and jump directly to it. We don't have to follow the references and start at the very beginning. So those are the two main considerations that you want to think about if you use linked list versus array list. And then the list interface really supports that you implement towards an interface, not towards an implementation. Okay, thank you for watching.